Okay, so it says initially at 0, the particle moves in the positive direction until it reaches its maximum displacement from 0. The particle then returns to 0. Okay. Note, guys, see here it says initially at 0. So what it's actually saying there is that's an initial condition. Again, I'm always like looking out for these initial conditions because sometimes they get hidden. So the initial condition is when t is 0, s is 0. The displacement is 0. Anyway, we'll come back to that. Let S meters represent the particle's displacement from O, and S max its maximum displacement from O. Let's do part 1 first, guys. Show that the time t taken for the particle to reach its max, S max, satisfies this equation. Okay, so let's try and get this straight in our head. It says the particle moves in a positive direction until it reaches its maximum displacement from O. So that's the key here, guys. It moves in a positive direction. In other words, V is positive until S max. Then V becomes negative. Or in other words, it reaches its S max when, so I'm going to say when V equals 0. When V equals 0, well, S equals S max if you like, but I'm just going to write S max. So it's at its maximum displacement when the velocity is 0. Because think about it, he's saying he's driving the car in the positive direction like this, driving, and when he reaches his maximum displacement, then his velocity becomes negative and he moves backwards that way. So you can think of it like that. So but right at this point here, his velocity is actually 0. So we're gonna solve that equation that we have from the first from part A. So part A, if you remember, guys, from part A we had V is equal to 1 plus V0 e to the negative t minus 1. This is from part A. So I'm just going to sub into this 0, and for t, I'm going to sub in t because it says capital T, because it says the time taken capital T to reach S max is this. So I'm going to say 0 equals, so 0 for V equals 1 plus V0. That's fine. The V0 is in the solution here. E to the negative capital T minus 1. Nearly there. Nearly there. I just need to add 1 over here. So I'm going to have 1 equals 1 plus V0 e to the negative t. And then I can say e to the t, because this is negative t here, I can say that e to the power of t is equal to 1 plus V0. And that's it, done. That's part I. Part I, he says, let me draw a line under this. Here he says, by solving an appropriate differential equation and using the results from BI, find an expression for S max in terms of V0. Right, again, this is a bit like the first one. We were solving a differential equation. We're going to solve a differential equation here, but with S instead of V. So I can write V as ds dt. So ds dt is equal to 1 plus V0 e to the negative t minus 1. This is a separable differential equation again, because I just have a function of t on the right. So I can say ds is equal to this 1 plus V0 e to the negative t minus 1 dt. So that's all in a big bracket, if you like. And then I can say the integral of this is equal to the integral of this. The integral of ds is just s. The integral of this, so v0 is just a constant, guys. That's the initial velocity. So this is just a constant. So I'm just integrating e to the negative t, which is just negative e to the negative t. So it's going to be negative 1 plus v0 e to the negative t. And then minus 1, the integral of minus 1 is minus t. And don't forget my plus c, add on a constant. Now this is where, guys, we have, remember I had initial condition. The initial condition is when t is 0, because I need to find this c. But I know when t is 0, s is 0, so I'm going to sub that in here. So I can write it like that. When t equals 0, s equals 0. Sub it in. 0 equals negative 1 plus v0 e to the negative 0, or e to the power of 0, minus 0 again, plus c. This becomes 1, this is 0, this is 0, so c is equal to, I'm going to add this over here, 1 plus v0. So c is equal to 1 plus v0. Okay, so we're trying to find an appropriate an expression for S max. Okay, so S, let's write out what is S. S is equal to minus 1 plus v0 e to the negative t minus t, that's this, I'm just writing out this, plus, but instead of c, I'm going to say plus 1 plus v0. Okay, now over here, I have e to the t. Let me scroll down here. I have e to the t equals 1 plus v0. So what would t be? So what would t be that satisfies this initial condition? Because this is, t is, let me just go back up here. T is the time taken for it to reach its max, and it satisfies this equation. But I can find t. If this is e to the t, then I can say t is equal to ln of 1 plus v0. I can say that. I'm going to put that in a box. You can. You certainly don't need a box here, guys, but just to be clear that this is coming from this, and then I can sub it into this. So I have S equals negative 1 plus v0 e to the power of negative 1 plus v0. Sorry, hang on, what am I doing? Negative ln of 1 plus v0. Again, guys, I don't need the modulus signs because it says at the start v is greater than negative 1. So this is going to be positive anyway. Minus t is again this, so it's ln of 1 plus v0 plus 1 plus v0. Okay, nearly there. This is a little bit complicated. Do they have a solution that they want me to put it in? No, well, it just says in terms of v0. So this is actually in terms of v0 here, but you don't want to have an e to the power of an ln in the one term, because I can simplify that. So S is equal to minus 1 plus v0. This is actually e to the power of ln of 1 plus v0 to the power of negative 1, which is 1 plus v0 to the power of negative 1. So hopefully, guys, you're okay with me skipping this step, but I'm going to write this is 1 plus v0 to the power of negative 1. Well, let me just show you very quickly in a different color why this is the case. If I say, really, it's e to the power of ln of 1 plus v0 to the power of -1. I can bring that, because that's a 1 there, if you like, I can bring that 1 up here, it becomes -1. And then e to the power of ln of x is x, so it's just e to the power of ln of this is this. So that's why that works. Anyway, let me continue. That minus ln of 1 plus v0 plus 1 plus v0. This times this is just 1 because they cancel. So s is equal to -1 minus ln of 1 plus v0 plus 1 plus v0. The ones cancel, so s is equal to v0 minus ln of 1 plus v0. So this is s max. So s is equal to this. I could say at s max, or when t t is equal to ln of 1 plus v0. But this is the solution here. Okay, that's it. That was a long question. I'll do the next part in the next video.